Welcome to Meki Techie. Learn as engineer, teach as champion. I would like to thank my family for their continuous support for making these kinds of video in a technical technical video in a public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore. And I would like to thank Almighty, my friends, followers, and my dear students and my subscribers. Today, the topic of interest is build drive. Here, the build drive is a very interesting, important drive. We have a drive for the shorter distance. We can use gear drive. If it is for a longer distance, we can use a chain drive or a rope drive. For the moderate distance, we can use belt drive. And here all the shafts are should be parallel, then only the belt drive are possible. The main difference between the belt drive and the chain drive is the chain drive is of a positive drive, whereas belt drive there is a slip, that is why it is not a positive drive. The belt drive, the applications of the belt drive is very much important and interesting, where in nowadays we have an engine with overhead camshaft, and the transfer between the uh, timing gear to the cam drive, we are using a belt drive. In previous days or ancient days, 2 decades before, we are using a chain drive. The chain drive is producing unnecessary noise and vibration to the engine. Therefore nowadays we are using a toothed belt drive. So that much interesting, and application wise very interesting things are happen in the belt drive. And moreover, nowadays the automatic cars or the scooter kind of vehicles having a CVT, continuous variable transmission applications, they are using a toothed belt drive. And it is a very interesting thing. Nowadays automatic cars are having the belt drives. So that much is important towards the belt drive. Let me discuss the belt drive. The belt drive important thing is the shafts are parallel, then only the belt transmission is possible. And very interesting and important thing, both in the belt and chain drive, the driver and driven member will rotate in the same direction, whereas in the gear, driver is in a clockwise direction, I say, the driven is in the anti-clockwise direction. The components of the belt drive are belts, pulleys, and shaft. There are two different types of orientation in the belt drive, which is open belt drive and crossed belt drive. The main difference is in the open belt drive, the driver and driven are in the same direction, whereas in the crossed belt drive, it is in the opposite direction. Both open and cross belt drive you can easily see in the planar mechanism. The machine tool planar is operating by means of a belt drive. There, open pulley is for the cutting stroke, and the return stroke we use a crossed pulley, crossed belt drive. For that purpose, the application of open and crossed belt drive we can easily see. Different types of a belt drives are flat belt drive and V-belt drive. First, we have to discuss flat belt drive. The flat belt drive velocity ratio is the ratio of velocity of the driver to the velocity of the follower or driven. The velocity ratio of the belt drive is very much important. That is why for the belt drive, velocity ratio is an important one. And slip is a negative phenomena of the belt drive. This slip will make the belt drive into a non-positive driving mechanism. Here the slip in the belt drive, which will decrease the velocity ratio. Slip in the belt drive will reduce the velocity ratio, and also creep in the belt drive having an uneven extension and contraction of the belt when it passes from tight side to slack side. The flat belt drive, next one is the length of the belt. The length of the belt, for your information, flat belt drive is not a closed belt. It is having a open belt. According to the center distance, the flat belt length can be adjusted by means of cutting the different lengths. For that, the belt length is very important. If it is a open belt drive, the L is equal to pi into R1 plus R2 plus R1 minus R2 the whole square divided by C plus R plus 2C. Here L is the length of the belt, R1 is the radius of the driver pulley, and R2 is the radius of the driven pulley, and C is the center distance between two driver and driven shaft. For the crossed belt drive, the only difference is instead of minus in the open belt drive, here we are using positive plus symbol. Therefore, the length when we compare to open and crossed belt drive, the crossed belt drive length should be more than open belt drive. Next one is the power transmitted by belt. Here P is equal to the difference of tension in tight side and slack side into velocity. That is the power transmission formula. The P is equal to T1 minus T2 into V. And the next, the ratio of the driving tension is T1 by T2 is equal to e power mu theta. Therefore, if we want mu theta, we can use 2.3 log T1 by T2. Next is an important and interesting concept, that is centrifugal tension. Centrifugal tension is occur at when it is occur at low speed, it won't produce any effect. When it is in the tight speed, it will produce more effect. That is Tc is equal to mass into velocity square. This maximum torque is equal to 3 times of centrifugal tension. Maximum tension is equal to 3 times of centrifugal tension, and it will produce no effect on power transmission. It is very important one, and it reduces the power transmission, and it will increase the belt tension, where velocity V is equal to square root of T max by 3m. Next, it is the Vbelt drive. Vbelt drive, it is very different from the flat belt drive. In the flat belt drive, belt are in the flat as well as it is not a closed format. The Vbelt drive are having a V in nature. The pulley of the flat belt drive is in a flat or a crowned shape, whereas for the Vbelt drive, the pulley should be in a grooved as per the V shape, and the belt is very much closed. The belt here, the belt touches sides of the pulley only, where the flat belt drive, the bottom side of the belt will always sit in the pulley. Therefore, the flat belt drive is having a lower pair, whereas the V-belt drive having a higher pair. The most of the factory and workshops, the V-belt drives are used. It is suitable for the shortest distance. The included angle of the V-belt is 30 to 40 degree. This thing you have to know very well. And in the multiple V-belt drive means instead of one belt we are having two or n number of belts as per the torque required to transmit. In the multiple V-belt drive, all the belts should be stressed in same rate and equally loaded. That is called uniformly loading. In multiple V-belt, the important thing we have to notice is when the V-belt drive, multiple V-belt drive, if any one belt is getting damaged, we should compulsorily we should change all the belts. All the belts should be replaced. Here, the driving ratio of the V-belt drive is T1 by T2 into e power mu theta divided by cosecant mu theta cosecant beta. Here, the driving ratio, we can also make that 2.3 times of log T1 by T2 into e power mu theta cosecant beta. Here we know that a rope drive, the ratio of driving tension is same that of the V-belt drive. In the rope drive, the ratio of driving tension is same that of V-belt drive. And we followed that the points to remember: the initial tension is the average tension of the tight and slack side of the belt. And next one, virtual coefficient of friction is always greater than actual coefficient of friction. That is, omega mu dash is always greater than mu. The total slip occur in the on the belt drive when the angle of rest is equal to 0. At the total slip, the angle of rest is 0. Next, in the flat belt, the crowning is there, crowning which prevents the flat belt drive. Crowning is present in the flat belt drive. This mechanism reduces the slip in the flat belt drive. And the important factor is to prevent belt running off the pulley. The crowning is needed. Next, stretching in belt. Stretching in belt is controlled by reducing belt stresses. And mostly the belt materials are made up of rubber, has a high or a maximum density. The angle of contact is taken for the smaller pulley, and the slip in the belt drive N2 by N1 is equal to D1 by D2 into 1 minus S1 by 100 minus S2 by 100, where V2 by V1 is equal to 1 minus S1 by 100 minus S2 by 100. The belt drive transmitting maximum power when the driving tension on the tight side is twice that of the centrifugal tension. That is, T maximum is equal to 2 times of Tc. The limiting tension ratio of the V-belt drive is T1 by T2 e power mu theta by sine alpha. Here the sine alpha becomes 1 by sine alpha is equal to cosecant alpha or a cosecant beta. We can say mu dash is equal to mu by sine theta, where mu is the effective coefficient of friction, mu dash is the virtual coefficient of friction. The vertical belt drive, the centrifugal tension is more than the initial tension. Centrifugal tension is more than initial tension. The initial tension T0 is equal to T1 plus T2 by 2, whereas with the centrifugal tension T0 is equal to T1 plus T2 plus 2Tc divided by 2. I hope that you have get enough details about the belt drive. With this, I am closing the belt drive session. If you have any doubts, please let me know in the comment section, and I will put a different video for your doubts. Thank you all.